Hi there. I'm Michael Smith. I'm a free range chief technology officer and general all around internet security dweeb. And Sam, who are you?
Hi, folks. I'm Sam Schneider, security geek extraordinaire. And I like that free range comment, by the way. I'm thinking of you as a chicken now. I
I
don't know
am a
why.
chicken. See here, you can do the chickens. So hi everybody. Today we're talking software defined radio, a little bit of what is it, what does it do, and then maybe you have a software defined radio. We will get you up and running and able to connect to, or not connect to, but listen to commercial radio stations and use some of the software that's out there. Okay.
All kinds of stuff you can do with that, right?
Oh yeah, totally. We get into all sorts of mischief. Fortunately, and something that probably has saved me several times, most SDRs are listen only, so they can only receive. Once you start transmitting, then things get kind of interesting, and you look at capabilities and you go, "Yeah, maybe that's probably something I'm not using legally."
Yeah,
Okay,
yeah. That's a
when
big question, right? And if you're just getting into the space, you definitely want to be familiar with the laws, right? Especially from the
yeah,
FCC or FCC. Yes, thank you. You know, RTL SDR, listen only, that's a good place to start. You get into more advanced, like the Portapack, you're going to, you have the ability to transmit, so you need to be very, very careful of that.
yep. Yeah, definitely. So you use video signals and SDR yourself,
Oh,
right?
absolutely.
So you've got different hobbies that you do. You want to talk a little bit about those?
Yeah, well, I kind of got into this because I'm a pilot. And a couple of years ago, they started instituting this new ADSB, automatic dependent surveillance broadcast, right? And this basically
Sounds
gives,
ominous, by the way.
I know,
Surveillance
but
broadcast.
it's really, really cool, right?
Yeah,
So it allows aircraft to talk to ground stations and talk to each other and vice versa. So we can actually get distance measuring information, our proximity to other aircraft. We can get all kinds of cool information. So even with the RTL SDR and something like SD Sharp, you can actually start picking up ADSB signalage and there are some really cool videos out there, like Darren Kitchen had one from Hack 5 that basically allows you to create your own custom ADSB antenna. I could pick up aircraft 400 miles away. It's pretty
yeah,
cool.
that's pretty good. I run an ADSB, just a listener, and it's running off a Raspberry Pi, and it's just the USB dongle and then the antenna. I run that in my bedroom because that's where I have the most exposure. Don't get too weird about it. But that sits there and it runs a piece of software called PyAware that it just listens to the airwaves, grabs the ADSB signals, gives me a local portal so I can see what airplanes are around, and then it reports it back to a like the master unit that keeps track, and then there's a little bit of like intellectual property things, but it keeps track of all that, and then that can update like is why is my plane late, because they can correlate the airplane ID to the current location, basically crowdsourcing the locations of airplanes around the world. And then I know people who use that for OSINT, so they're tracking, like the people that I think they just introduce a bill for it, but they track Taylor Swift, Elon Musk, folks like that.
So there are all kinds of tracking sites out there, commercial tracking sites. You can literally put in an aircraft designator or a tail number or a flight number, and you can get, like FlightAware, for example, you can actually see what's going on with that flight. You can look at the path. You can look at its statistical data against that as well and say, hey, this flight is on time 85% of the time. Most of my flights here where I'm at are much less than that.
The accuracy is a little bit low of when the airplanes show up. Yeah.
But there are all kinds
Yeah,
of things you
fair.
can do with this, right? I mean, not only ADSB, but also being able to pick up satellite or satellite data transmittals that are happening out there. And that's very, very cool. Looking at signatures on things like garage door openers or key fobs, things like that. You can actually look at that, interpret that signal. You can record those signals. You can do some pretty fun stuff with that from a hacking perspective.
Yeah, one of the things that I do a lot of is smart meters. So smart meters have a broadcast system. So it's designed so that the meter reader can just drive a car with a bunch of radio gear in it. They just drive down the neighborhood, or they have a handheld version that you just drive down the street and it collects all the meter data, which means that they can basically spend less time reading it. Right? And they don't have to manually go and record everything, which has errors and things. So they just drive through and record it. But that also means that there's a radio signal that you can actually listen to. And so I've done quite a bit with that. You can do a lot of automation where you can use a piece of software that grabs telemetry. Like one of the things that I have, and we'll do a video on this at some point. But I've got a ThermoPro barbecue thermostat, right? So you got the front end that's there that plugs into your pork ribs. And then you've got another unit that just shows you what the current readings are and has an alarm. So you set an alarm for a particular frequency or for a particular temperature. And that way I can sit up here in my office while I'm out in the back patio. I've got barbecue going on. And you can actually grab those signals because they're just amplitude shift keying. Like, it's simple radio signal. There's no encryption or anything. You can grab that radio signal, dump it into MQTT, and then have a software agent that checks MQTT that performs actions based on the temperature of your meat.
Yeah, that's very cool.
So it's really useful in home automation. What? You can change the lights, right? You can change the lights, like when, you could have literally a heat light. And when your meat is cold, it's blue. And as your meat gets warmer, it changes closer to a red. You can do really fun things.
I'm
Yeah.
I'm not talking about meat temperatures here.
Mm-hmm.
But seriously, being able to tie that into MQTT or any type of API interface for home automation really adds a huge element to it. And yes, you mentioned encryption and signalage. And we were talking about ADSB earlier. And one of the biggest problems I have with ADSB is the lack of encryption on that protocol. So
Yeah.
we'll get into that.
It's good and it's bad, right? So it's good because everybody can read it, so you can find out who's around it. But it's bad because,
if you're a bad guy, it's real bad.
You can track Taylor Swift. But also, if you inject your own signal, you can say, "Hi, I'm Sam's plane, and I'm here," and they route everybody around you, or it causes alarms for everybody when you're not actually there.
That's very true. I mean, it could lead to some very serious circumstances if that data were manipulated, by an adversarial group, for example. It could cause collisions. It could cause all kinds of things, all kinds of problems it could cause. But that's something we can explore.
Yeah, definitely. So let's get into, like, how did I get involved in this? So back in a past life, I grew up in the Northern Rockies. There was nothing there. I joined the Army. They said, "Hey, you're pretty smart." Sent me off to language school, taught me Russian, later on Serbian. And then I was a signal intelligence operator, right? So I'd sit with my headphones on, just like I am today, listening to people driving their tanks around, in places. And it's been an interesting couple of years with all of Ukraine for me, for various reasons. But, I did that, and I did direction finding, I did jamming, I did just regular intercept and hand copy, like live translation stuff. I did a little bit of stuff with data bursts. And then I didn't really do much with it, right? It was like, okay, yeah, radios, that's a thing. Then I started teaching a class on IoT security, right? And so part of that class was software-defined radio. And so I got my instructor hobby kit, which is like, here's some Arduino stuff. Here's some ESP8266, Arduino-compatible single-board computer. Here are a couple SDRs. Here are some some of these things. They're like little radio transmitter chips that you can wire up to an Arduino to send little data bursts. So they started giving me all this stuff, and I started to mess with it, and I was like, hey, wait a minute, this, like, I know this stuff. This is like, yeah, I've done this before. And in the meantime, they have all of these decoders for signals and data burst systems that you could really start to explore the world around you and learn what kind of signals are coming around you. And so I started doing that, and then I got up to the point where I lived close to a major hospital, and I was intercepting all the pager traffic that they have, and I was like, wow, okay, this is a big deal. Listening to basically the stuff you'd use a regular radio, you'd use a regular radio scanner for, so police, fire, folks like that. And just started messing with it. And over time, I've added a lot more capabilities to what it is that I can do. Okay.
It's amazing too. It's a whole other world out there that most people never hear, never see, are not aware of. It's there. It's always been there. And as technology continues to advance and more devices are communicating out there in the open air, it's an invisible world, and it's full of all types of things to explore. But you need to be careful about that.
Yeah. So SDRs themselves, okay, they are software defined radio, right? Which, to use the wonderful English phrase, it does what it says on the tin. Okay. So in other words, it is a radio that has a hardware component, and that's what people normally think of as the SDR. But it also needs software to be able to decode what the signal is. And the way that the SDRs work is they have an analog to digital converter, right? So if you think of the radio spectrum, and you have different frequencies, and you have the height of a signal that's there, or the strength of a signal that's there, what they do is they break down that spectrum. You set them at a base frequency. They grab that spectrum and transmit the strength of each, like even little sub chunks of the spectrum, and they transmit that as a stream of data, which basically says this frequency, here's the signal strength. Okay, that's all the SDR does. And then it converts it to USB and pushes that traffic over USB to a computer. The first ones that people started using were built for TV. So they were advertised as TV tuners. So you could plug these things into your computer, load up the software, and you could watch TV. Okay, or capture TV, as the case may be. But it was for the old school TV, when the TV went across the air.
Hey, I still use over the air. What are you talking about?
Like,
I'm a cord cutter.
I haven't watched over the air TV in a long
I watch
time.
it every day.
Oh, I did when I was in Germany. Because they have the antenna. The antenna has a cable that comes down into your house, so you had like a jack there to get into the antenna. But that was, I left there in 1998, 1998, 1999, 1999. So I haven't used regular broadcast TV in this millennium. But anyway, so these things were originally made to grab television. And some smart people sat down and said, hey, wait a minute, these things, because of the way that SDR works, where it just samples and provides a data stream, you could actually build your own software to decode the signal. And because it's a data stream, you could use software like Python. In fact, a lot of the utilities are built using Python libraries. But it's a data stream, so you could dump it into pandas in Python, and then you could do mathematical calculations from that, and it would help you to decode even more data. And so you do really need the software to decode it, but it also means that people can write a bunch of different software, and there are a lot of different pieces of software that are out there that to help you control the radio and to decode signals. Okay. There is one thing. Let me share a little bit of stuff here. So there is a company called Noelec. They pretty much make the majority of these that are out there. They, including the Hack RF. So they make the Hack RF that we'll talk about here in a second. But you'll see they have a series of these things, and you'll see right here the tuner IC. So that's the actual chip that does that analog to digital conversion. Most of them are going to use that RTL 820T2, right? Or 820T. And you'll see that in a lot of these. Most of these are the same. You'll see the smart, and this is a little bit older. This was from 2 years ago. It's still valid. But the Nesder, so Nesder is Noelec SDR. But they've got these guys that have an aluminum case. I've had one here on my lap. What did I do with it? Here it is, right? So it looks like this, right? So I've got one of those. It's got a nice aluminum case, and it has an SMA connector. And I'll talk about connectors here in a bit. But that's kind of a nice one. They sell for like $40, $50. Okay, depending, you can get kits that have antennas and stuff like that. Then they also, down here, you've got the Nesder Minis, and those have a, thermo resin, aka hard plastic. They've got the thermo resin, and the connection is an MCX, which is like a little hole that you just click in, so you don't screw in the antenna. But these things are $25 to $40. Okay. And so for $50 worth of kit, you can go out and start experimenting with these things. It's incredibly approachable, incredibly accessible. Okay. And then on the software side, there's tons of different software you can download. I'll take you through GQRX today, but there are a bunch of others. There's SDR Sharp, SDR Angel, even stuff that runs like headless from the command line that will dump data. In fact, there's one that's dump 1090 that just does ADSB. It's a busy stream, unless you live in, the wilds of West Virginia or someplace. Roanoke. You live in Idaho, you're not going to get a lot of signals. I guarantee it. But it otherwise it's pretty busy. If you live close to an airport, it's going to dump a lot of data for you.
It's too busy sometimes.
Yeah, too busy. You can't keep up with it. But there are all these decoders that are out there, right? And almost all of the software is free, and free as in free speech, and free as in free beer. Okay. Most of it's open source that's out there. Okay. There's another one that a lot of people in the hacking community started. Oh, by the way, all of these, a couple things to note here is the frequency range. So most of them are 0.1 to 1750 megahertz. So that's 1.7 gigahertz, which doesn't get you up into the Bluetooth, Bluetooth, Wi-Fi. It's going to be below that. But there's a bunch of signals that are right around, like a lot of toys are 315 megahertz, 433 megahertz, 868 megahertz. Your smart meters are right around 912 megahertz. So it gives you a pretty good range of things that you can actually listen to. And let's see, do they actually have it here? They don't list it here, but all of the Noelec SDRs are receive only. So you're not going to transmit. Okay. That's a good thing. That's a happy thing. Okay. Keeps you out of jail. Must be this high to commit illegal acts. That's good. I'm down with that. The Hack RF1 goes from 1 megahertz. Here, let me blow this up a little bit. The Hack RF1 goes from 1 megahertz to 6 gigahertz. So that puts you in the range for a lot of other interesting things, especially some of the more advanced data burst signals, and it puts you into that kind of Wi-Fi, Bluetooth signal range. Now, you can't participate in those networks. It's not a Wi-Fi dongle, simply because you do have a receiver and a transmitter, but it is half duplex. So you can either send or receive. You can't do both at the same time. Okay. Now, could you like buy two of them and you transmit on one, receive on the other? Yeah. Could you pair it up with a different SDR that does receive while you transmit? Yes, you could, but the software gets a lot more complicated. Okay. The big thing with the Hack RF1 is that it's got that bigger range, the bigger operating frequency, and that you can actually transmit data with it. Okay. And that makes a huge difference. The other thing that both Sam and I have is a Hack RF1 Portapack. So somebody a couple years ago, right? Hack RF1 has only been around for 8 years ish, I believe. Fact check me though. Don't, citation needed if I was Wikipedia. But somebody sat down and said, okay, we've got the Hack RF. It's a radio, it receives and it transmits. And so could we take that? And you'll see here, I'll click in on this. They took that and they added I would do like that. They added a case. They added a 5 button pad. They added a dial, and they added a touch LCD and a small single board computer to it. So if you take this apart, the bottom side of it, or the bottom part of it, is your normal Hack RF, but then it uses the headers on the Hack RF to connect into this other unit that has the LCD and the buttons and things. And you can put firmware on it in order to be able to do functions directly on that particular unit. Now, me personally, I've got mine right here. This thing travels with me everywhere. And you'll see here, you've got applications that allow you to receive data. So your ADSB, there's another version or something similar that is AIS, where you can grab boats. You can grab weather balloon data. So you send up it's called a radio sonda. You send up a weather balloon, you can get all the data and telemetry out of that. You can grab MAC addresses of Bluetooth devices, a bunch of different things like that. It also has transmit. The transmit, know what you're doing. You have to be at least this high to get on this ride to do illegal acts, because there is a jammer. There's transmitters for several different things. There's a GPS spoofer. There's a bunch of other. That is mayhem, and in fact, that's what the firmware is called. The firmware that you put on it is called mayhem. Okay. One of the ways you can stay out of jail is if you build a Faraday cage. Okay. You probably have one in your home already. We call it a microwave oven. But a Faraday cage is a mesh or a cage made of metal that you apply a little bit of electricity to, and it makes a dead space or a barrier that radio signals can't come in and can't leave. Okay. And so I do this a lot. I've also do like Proxmark stuff. So hotel cards and like the cards that have a little RFID chip in them. And because I have like a big stack of these on my desk, I will put my reader into a Faraday bag to make sure that I'm not reading any of the other cards that are sitting on my desk by accident. Okay. But you can do the same if you want to experiment. You can actually use these as lab equipment, right? So you can use these as lab equipment if you have two, like nerdy me. You can transmit on one, receive on the other, and you can, learn about what the signals are, because now you can send and receive.
Yeah, so Mike, about the Faraday cage and the microwave thing, I know that's been popularized with Edward Snowden, talking about putting the phone
Yeah.
in the microwave and so forth. But that filter, that mesh, is tuned to a very specific resonant frequency.
Yeah. Yeah.
So be very cautious with that, because what that means is that if you put a telephone in there, Do not turn the microwave on.
Oh my God,
If
don't.
you're going to do this, please don't fry your equipment. But
Don't, yeah.
put your cell phone in there and have someone try to call your cell phone and see if that works. Prove or disprove it yourself. Always be thinking on your own. Don't ever take someone's word for it, but always, test it before you try something out, because, you could hit the magic frequency and the microwave doesn't prevent it from actually transmitting out, and you could get in a lot of trouble. You hit something like an FCC regulated frequency, like air traffic control in your local space, or police, fire, and rescue, and you start broadcasting on that, you're going to have people knocking on your door. So we don't advocate that in any way. Just test it out and be cautious with what you do.
Yep. If you're going to be a criminal, be a smart criminal. Right. Because they do have direction finding kits. They will like set them up. Direction finding is nothing new. We've been doing it since, at least 1917. One thing that you'll see here in this particular packaging is that they sell you a bundle, right? And a lot of people who sell SDR kit will sell it as a bundle. And out of this, you get a telescoping antenna, you get this funky whip antenna with a base, you get another, like this is the rattler, or the can, you get the paddle. I think that's all. Here's another one with the base. And they're for different frequencies. You'll actually see they're listed here, right? So this paddle one is built for 2.4 to 5.8 gigahertz. Okay. And so there's a big deal where you really try to match your antenna to the signal that you're receiving. However, I will be honest, if you look on my video here, I've got an antenna 700. It also comes from the HackRF folks. And it's a little stubby, right? So like hand for scale, it's 7 centimeters. I'm sure it actually says here. It goes from 9.5 centimeters. So it's just a telescoping antenna, but because of the size and because it can match like most of the signals that I want, I just travel with this and I keep it in my bag. And 99% of the time, that's what I'm using for an antenna. I do have a bunch of other ones. So I've got this monstrosity. This is hand for scale here. This is a magnetic base. And it's got an SMA connector. I'll get into connectors here in a bit, but it's a little screwy connector here. And so you can take this, and it's got rubber on the bottom. It's designed to like slap onto your car. You screw in your favorite antenna, and then you can drive around. I probably wouldn't take it on the interstate, but you can drive it around. It might go flying. You might need to buy a new antenna, but you can take this and screw it on and drive around and collect signals and transmit signals wherever you want to go, right? So I've got like this big, huge one. There's a smaller one that I have, but you'll see it here. They're just a bunch of different ones. Like these little guys have magnetic bases. You can do the same thing, but I'm sure I'm killing my hard drives in some way, but I just slap this on my metal computer case, and I just keep it there and, collect signals.
Well, Mike, let's talk about why that's important, though, because if you're targeting specific types of activities, for example, you want to look at a dongle, right? For example, you may want to use a targeted antenna so that you maximize your signal pickup. And actually, Mayhem has a tool, a utility on here that allows you to customize or determine what the best length of an antenna is for your specific application. So you can put it in there and you can go back and look at that. Very, very important though, if you want to get quality signals and you're doing analytics on it, that helps you get a better signal.
Yeah, totally. And if you're just receiving, it's not as important. You want to be close enough. But once you start transmitting, you have to be really careful, because if your antenna reflects too much too much noise back into the radio, you could actually cause it to heat up or make the magic smoke come out. Okay. And that's not good. And so that calculator, what you do is you put in the input the frequency, right, in megahertz, and it will tell you what the length of that wave is. And so higher frequencies have smaller waves, and lower frequencies have bigger waves. Okay, and that's just how they work. And so you want to match the length of the antenna to the width or the length of that particular wave so that you capture each wave at a time. Okay. And you can do half length and quarter length and full length, which gets hard with the lower frequencies. Like the full length for it HF is like the size of a house. I've had antennas like that. It's pretty nerdy. Okay. There are also connectors on these things, and I mentioned this briefly, but there are two connectors that you'll see primarily on SDR stuff. The first one is the SMA, and the SMA looks like this, and it's got a pin in the center. And then the female has the screwies on the outside and no pin, right? And those you'll find, in fact, the HackRF F1, the PortaPack, and the better Nowelec SDRs have an SMA. They've got a SMA female on the unit, and then the antenna and the cable have a male SMA. Okay. One thing to be careful with is that there's something called a reverse polarity SMA that's used on all your Wi-Fi gear. And you'll see here for the male, so the male goes in and it's got the outside screw and kind of that like screw nut that's on the outside. But you'll notice it doesn't have a pin in it. Okay. And the RP-SMA female, so that's usually on your Wi-Fi router itself, has the pin that's there. So you take this male RP-SMA and screw it in over the top. This is the male side is usually what your antenna is. If you take an RP-SMA antenna, it has no pin, and plug it into the side of your SDR, which has no pin, it won't work. Okay, it's basically no antenna because there's no pin to connect things. Okay, and if you try to take this, you try to take an SDR SMA plug, the antenna, and plug it into your Wi-Fi access point, it also won't work because you have two pins. Okay, so there's nobody has the female side to actually plug stuff into. Okay, so those are the most common. On the thermoplastic ones, you get an MCX. Okay, so the like these guys, the thermoplastic SDRs, they've got an MCX plug. And so you'll see these ones, they just pop right in. So they've got like a spring on the inside. You just shove it in there and the spring goes click and you're connected. Okay. It's a cheaper connector to build, but it's also not as steady and reliable. It's just not as steady and reliable. But if you remember back in the old days when you had Wi-Fi and you had PCNCIA cards, the antennas for most of those, oh my God, what did I do? Most of those will be most of those will be like an MCX or a micro MCX. Okay. Now, having said all that, I do have an adapter, right? So if you look right here on my video, right there, I've got an adapter. It just looks like this. It's got, right, my focus there. So it's got an MCX on one side, and then on the other side, it is an SMA screw. So I can take that, just plug it in, pop it into the SDR, and now I can use all of my SMA antennas using that MCX. So I've got these things. These things usually travel with me. I've got one that just stays attached to a whip antenna so that wherever I go, I can go, I can use whatever antenna I want. I don't have to worry about mixing and matching antennas. Okay. I think that's it. Antenna wise, there are two. I showed you the ANT 700. They also have an ANT 500, which is a longer one, so it goes 20 centimeters, so 9 inches, all the way up to 88 centimeters. So what is that? Like 2+ feet. Okay, probably like 2 feet 4 inches, 2 feet 6 inches. Okay. And that's a bigger, longer one. It just doesn't travel as well. But I have one of those. But you can go find antennas. Antennas are funny because everybody gets like crazy about antennas. Most antennas will work for whatever purpose, they just won't be optimum. Once you start transmitting, then you have to worry about it.
Yeah, I think the 700 is a great choice starting out. It has a broad range, and it's a good starter antenna.
Yeah, definitely. Definitely. And that's why I have a couple that live in my bag. Um, Yeah, I have a couple that live in my bag. This Hacker F Portapack, this lives in my bag. I've got one of these guys that lives in my bag, and I have a Proxmark, which is used for RFID stuff, or the contactless NFC cards. Um, so I have that, just lives in my bag. So wherever I'm at, I can go explore stuff. Okay, by the way, going to the airport for me is kind of fun, provided that I have noise canceling headphones. Um, because like I hear all the noise around me. But I take my Portapack and I go use so I go to the Boston airport, which also has ships around there. So I can go like grab all ship IDs and do a little bit of like ship spotting, and then I can do some plane spotting using ADSB. Um, So I think that's it on antennas. Now software, okay, and I mentioned this before. There's a lot of software that's out there, um, and there are different operating systems you can do, right? So there's software for Windows, software for Mac, software for any kind of thing. Right now, I'm running on an Ubuntu. Software is there. There's one operating system that's called Dragon OS. I met the guy who made Dragon OS, but it's a Kubuntu, or it's Ubuntu with KDE, right? So Kubuntu. And he took Kubuntu and added in his own sources and started bundling and releasing SDR software and a bunch of other radio software um, for this operating system. And I met the guy at DEF CON in the RF Hackers Village. He was walking around and he had a direction finding antenna in his sticking out of his backpack. And given my background, I was like, hey, that's a DF antenna. What are you doing? And then he had a Stream Deck that was running Dragon OS. So he's walking around the conference with this Stream Deck, which is normally used for video games. But he said it made it a great controller, and I don't blame him. We had a direction finding antenna and receiver with a remote control like that we called the Game Boy. Um, And funny enough, because the Game Boy had a liquid crystal display, when it was really cold, you'd have to sleep with it. Otherwise, liquid crystal displays, because they're liquid, they don't like being cold. Funny enough, they don't like it when it's like minus 10 degrees. So you have to sleep with the Game Boy. But anyway, I found him. His name is C Maxecutor. He's on Twitter. You can find him. He's doing really fascinating things. He's got a YouTube channel. He's way, way, way more stuff that I could learn from him as far as like different builds and different pieces of software that he's using. Okay. So there's that. I'll show you what that looks like. The regular generic receiver that most people use on Linux is going to be GQRX. Okay. Or how do you actually, can you pronounce that?
Call it
GQRX.
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 Nah, and it's definitely my favorite.
Yeah, yeah, by far. But RX is usually receive if you're a radio nerd. And then GQ is like good quality, well received, I believe, in ham codes. Okay. So it's there. It's open source. You can download it. Like you can install it in just apt-get it in Ubuntu, in Kali, in Debian. It's all there. You can just grab it. Okay. In Dragon OS is Kubuntu. It's apt powered, so you can just apt-get install GQRX SDR. Okay. Let me pull up a terminal here.
As I'll say, you're gonna walk through something.
Yeah, it's really easy. So I'm just gonna sudo -i. Okay, so who am I? Boom. So now I'm just running, and it's just literally apt. Well, all the cool kids nowadays. I'm old, so I get to say apt-get install GQRX-s. Okay, and I already have it installed, but it's GQRX SDR. Okay, and you can just install it, and then you just run it. But in order to run it, I'd actually have to plug in an SDR. So hang on, let me go run that over there. Drop that bad boy in. Okay, and I have to do something with my big honking antenna. You might be able to hear this when I slap it on my computer case. It makes a resounding thump when it sticks itself to my case. It's very tactical feedback. I like it. Okay, now let me make a GQRX here. That's going to look funny for a second. GQRX. Okay. Where are you at? So there's GQRX. Okay, now when you first start it, you probably won't get this display because you haven't taught it how to identify your SDR. Okay, it will in fact show up with a display that looks like this. Okay, let me make it a little bit bigger. And so what this is you just go in and you pick what device you want. In fact, you should see something that looks like this, which is a generic RTL 2832U. The 2832U is the controller chip. So you see something like that, or down here, I've got a Realtek RTL 2838 UHIDIR and something. Either one of those will work. That's just how the device identifies itself to the operating system. In Linux, there are a couple things that you need to do, okay? You can run this inside of a virtual machine. And what you have to do is up here under Devices, USB, you have to look down for the Realtek RTL 2838 UHIDR. You have to pass that through. So what this dialog does is it passes the USB and passes that directly through via VirtualBox to that virtual machine, and it'll show up in the virtual machine. Okay, but you can only have a USB device because it's serial, right? Universal serial bus. Because it's a serial device, you can either run software in your host that accesses it, or you can run software in a guest VM. You can't be in both places at the same time because that would cause a contention, and it breaks the rules. The rules must be followed. Okay? There can be only one. There's a lot of other cliches, but that's how you pass it through. Now, I also run in my basement, and this is a cool tool that I haven't heard anybody talk about, and I think it's really cool, is Virtual Machine Manager. And I've got a Dell rack-mounted server in my basement that runs an Ubuntu server. I tell Virtual Machine Manager to connect there. It connects via SSH, and it runs a display. So you can go in and set up virtual machines. Here I have Dragon OS that's running. And where with that view? Okay, so there's Dragon OS that's running. And I also have the virtual machine redirect USB device. And I can go in. It's exactly the same type of dialogue. But I can say, here's my Realtek RTL 28 go ahead and patch that through, even though it's running on a remote server, patch that USB device through. I've tried it. It works like a charm. It's actually pretty cool when you do it. There are other options, and we'll talk about other options probably at a later date. But you can also take a Raspberry Pi or a virtual machine, and you can connect it to an SDR, and you can run a remote control there. So you can take GQRX and say, oh yeah, connect to this remote server and grab the sound that's coming across, but play it all locally. So it just takes that USB stream, transmits it as a UDP data stream, and you can tap into that data stream and decode everything here locally. Okay, so you can also build that. There is that.
Yeah, don't forget also, if you have issues with it actually recognizing the device, drivers are key. Always. It's always more than likely going to be a driver issue. And we run into this in Linux, you run into this in Windows with SDR Sharp, but the driver is what you need to focus on if you have problems with your device. For example, you may believe that it sees the device because it shows up when you actually collect it. But when you go to actually activate the device and use it as a direct source, it doesn't load.
It doesn't.
It says device is not found.
It's like, what you talking about, Willis?
Right.
So especially if in VirtualBox, you come up here and you do the USB pass through and you don't see that the device listed like that, then you probably have a driver issue. Okay. One interesting thing that you can do in the Linux world is if you do ls USB, it will actually show you what USB devices are connected. And in fact, this is suspiciously similar to here inside of VirtualBox when you say this, because it's the same data source, right? But LSUSB, you can come down and you can see, where is it at? This guy right here, right? So it'll tell you what device, and here's the manufacturer ID, and then 2838, which funny enough coincides with the 2838. Okay, that's the actual device ID. That's the device ID, that's the manufacturer. But you can do that, and then usually what I'll do is pass the USB device through VirtualBox, then open up a terminal there, run LSUSB, and see if it actually passed through, and if that guest identified it as the right type of device.
Confirm but verify.
That is
correct. Trust but verify.
Yes. I'm a CTO. That is test-driven development or integration.
Test-driven. There you go.
All right. So once you get to GQRX, let's get back to GQRX. We'll get there. You want to say, oh, the device I'm using, I was experimenting with there's a bunch of different like lines you can put in here. We just want to pick the Realtek, this guy, and everything else should be okay. Like you can set the sample rate, which is how many samples per second it does, and a bunch of other things. Don't worry about it. You're okay with the defaults, but you do have to tell it which device you're using because it starts with, I forget what the default is. It might just try to record from audio, which is like crazy. But you pick that, say, okay, you should get here. Now, inside of this, it's kind of a busy display. I'll talk you through it. Over here on the right-hand side, you have receiver options, input controls, and the magical FFT. Don't mess with FFT. FFT drives the display. It's called Fixed Fourier Transform, which is basically making the scope work. Okay, ignore that. What you really want to do is go to the receiver options. Now, inside of commercial radio, which is what we're going to do, I believe the bottom for commercial radio is 87.5 megahertz, and the top is 107.5 megahertz. Okay, so we're going to pick something in between. And right here on the right-hand side, you have the frequency. Up here, you've got this up here. This is like your offset. So you want to set that to 0, just the 0, 0, 0, 0, 0. Clear that out. And then here under the frequency, you want to go, like I want to go 97,500, like that. And you'll see right here, it says hardware frequency, 97.5 megahertz. That's awesome. That's what you want to be. Now, commercial radio is using wide FM. So you want to put it in wide FM, probably stereo. Okay, so this is how the signal is actually encoded on the radio wave. And the common ones that you'll see is narrow FM, wide FM. So they actually, the signal is wide. And so like the low noises are a low frequency and the high noises are a high frequency. And that's really why FM radio has that good, rich depth of sound, because it uses different frequencies for different sound levels. Okay. Because music is sound and it has frequencies. Cool. And they tack it onto the signal. The other one that you'll see a lot of is AM, which is amplitude modulation. And a lot of devices in data burst and old school radio, right? Before FM, there was AM. AM radio uses AM. And what they do is, in order to send a sound, they increase the power or the height of that wave. And that's actually what makes the sound. So for today, we're going to be using wide FM in stereo. You want your filter width to set it to wide. We'll be okay there. The filter shape, just keep it at normal. And we should be okay. Down here, you have a button that says mute. And I want to turn mute on simply because the first time you turn this on, you get static. And that static might be loud and it might blow your speakers in a bad way. Okay? Then you come up here in the upper left-hand corner, there's a play button. And it says start DSP digital signal processing. Just, okay? And you'll see stuff immediately starts to happen, okay? Up here in the top, you have, this is that fixed Fourier transform. And you can actually see, here's a radio signal right there. And you, over here on the left-hand side, you've got a couple things. So you can, if you left click and drag, you can change what that scope views. And then if you scroll your mouse, you can shrink and grow the scope of what you're looking at. So I completely blew it out. Let's do something like that and then pull that down. So I get a nice clean signal. Cool. And this stuff over here is static. So if I unmute it, I'm not hearing it yet. Change your squelch. So there we go. That's where I'm at. Okay. So you'll see down here at the bottom, this is more FFT. This is basically what noise you're listening to. You'll see it's at minus 40 decibels to minus 60 decibels. So if I change this to something, this is the squelch. And the squelch says if the noise is below this amount, don't make the noise for it. Just ignore it. That's just the sound of static. And so as you increase this, right, and right here I hit 30, you'll notice this FFT down here just totally disappeared. So just a little bit is showing. So I'll pump it up a little bit. And so now I'm not actually hearing anything that is the signal. It's basically, just imagine it's a filter. Anything below that, it's just ignoring. Okay. Also down here, you have something called the gain. The gain is the volume. Okay. Gain is how radio people say volume. Just everybody nod. Okay. So that's your strength. Now I want to keep this kind of low, and I'm set up here. One of the things you can do is if you can go over here over a bunch of static, there's no real signal there. That's just static. And over here you have an A. hit A and it will automatically set what that squelch is. So you just mouse over, move that red bar in the middle over to something that's static, hit A, and it'll set your squelch for you automatically. Okay, and that's good. Okay, one thing that you want to check, especially with the no-elect SDRs, is you want to come over here to input controls, and there's one box here, checkbox here, which is hardware automatic gain control, which is the hardware when you enable that, it allows the hardware on the SDR to determine what's the right level of gain, or what's the right level of volume to send that sample back as. So in a lot of SDRs that I've messed with, you have to actually turn on the hardware gain control. I think it's enabled by default, so you're okay there. Now, going back to receiver options, okay? You can see here, I've got this nice signal here. That's what commercial radio station looks like. And you'll see that nice broad spike with a little bit of noise here and a little bit of noise here. This noise, I think, just might be an antenna connection kind of thing. And then down here below, you have what's called the waterfall, or you might hear it referred to as a heat map. And for some people, it might be blue and might be red over here, or it might be yellow and orange. I have yet to figure out like what the color code does. Don't worry about it too much. Just know that the more red it is, or the closer to red it is, the more signal is there. And you'll see it's kind of moving down. That's why it's called a waterfall. So the most recent signal is up at the top. The least recent signal is down at the bottom, and things just slowly fall off the waterfall. Okay. So what I can do here is I'm going to grab that red line that's in the middle of the signal, and I'm going to move it over on top of my signal like that. Now you can, this over here on the right-hand side, you see if I mouse over it, it gives me the arrows. That is actually the filter width, and think of that as a notch filter. So anything below that, and it's not going to give you the sound for it. Anything above that, and it's not going to give you the sound for it. It's only going to give you the sound for that gray area. And you can adjust it over here. You can say narrow, boop, see? Or, super narrow. Or you can say wide, or you can mouse over and you can grab it and you can drag it and it extends out to the place where it needs to be. For this one, I noticed that normal, filter, not the shape, the width. Okay, wide works absolutely great for me. Okay, and I can turn on my gain. And I can hear that, but you probably can't hear that because it's going through my headset, so you guys can't hear it. That's okay, but you'll see down here, I can see my signal here in my receiver options with the FFT. Now, if all this goes away, I got to mute because I can't talk and listen at the same time. It's very distracting. If this all goes away here, boom, boom, right? You can make that all disappear. You can just come up here to view and say receiver options, view FFT settings, view input controls, view audio, boom, right? And that takes you to like restore all of your views, right? Or you can go in and turn those off. Okay, cool. Just like we did the zoom and pan here, you can also do the zoom and pan down here with the frequencies, right? So you can zoom out, zoom in, you can grab and drag. At some point though, you drop off the end of the earth simply because of how the SDR works. You set it at a base frequency and a sample rate, and it will sample to the left and the right of that base frequency. At some point, if you drag it too far, you just drop off. There's no sample over here because of the way that the hardware frequency and the offset is. Okay. So that basically it'll drop off the edge of the earth because you don't have any data there. Okay. One other trick that you can do is up here, you can click and this changes the frequency. but you can also do 96, where am I at? 96.9000. You can just type in a frequency there and it will tune the radio to that frequency.
It's cool. I think what I really, really like about this particular application from an SDR perspective is it's easier to control, in my view. Of course, I'm used to a command line with Linux. The alternative SDR Sharp on Windows looks really good. It looks, as equally impressive, if not more so a little bit, especially up in the top graphing. But quite frankly, I think this software has more control.
Yeah. And it does have a lot of other stuff. This is subject for a later date, but you have UDP streaming. So if we go tools, you can run it as you can allow remote control where it listens on a port and takes commands from other software. So you can build your own server there. You have remote control itself. You have bookmarks down here. Wait, cancel tools. I'm not viewing the bookmarks. You can view the bookmarks, so you can set up different frequencies that you've listened to. There's an IQ recorder, which records the exact, like the data sample. You have a recorder down here that will record the audio that comes across. You can forward. So there is a UDP. So you can set up a UDP stream. I think it's over here in tools.
Yeah.
It's one of those, I've done it. And it's really cool because you can basically take a UDP stream and you can stream it to another machine, and then you can use decoders. You just use Netcat, literally use Netcat to say, oh yeah, take this, and then hand it off to another program and another program. And you can actually add different decoders that GQRX doesn't do natively.
Yeah, we can look at those because the decoding is critical if you want to get the right data, right?
Yeah, definitely. Definitely. So with that, let's wrap it up. So stuff that we've discussed today, we've discussed SDR, some of the purposes and what you can do with SDR. We introduced different varieties of hardware, different varieties of antennas, and we installed GQRX, and we used GQRX in order to listen to commercial radio station, just to prove that, yes, you can actually get this tool pipeline and hardware pipeline up and running and do things with it. In the future, we'll talk a lot of other advanced uses. But having said all that, I am Mike. Sam is Sam. And we will see you all in the next video.